Okay, so we're looking at the next part, which is matrices and transformations. And basically, transformation is a process whereby a point in a plane, and a point could be multiple points that make up a straight line or a curve. Anyway, these points are assigned a new position according to a rule. And these are the transformations that we're going to look at. The one I'm going to add is one more here is linear transformations. Now, this is going to take a few videos, but in this one, we're just going to be looking at reflections, and it's there's quite a few different ones. So copy those down and come across. Okay, so the first one we're going to do is a reflection in the x-axis. So basically, the point is being moved down to here as a new point, and we just label it P dash, which would be a new coordinate. But if you look at, obviously, the symmetry, the x value, the new x value is the same as the old x value, but the new y value is the opposite. So let's put a minus sign in front of what it is. And so the transformation matrix would be 1, 0, 0, minus 1, because that leaves x as a positive and that changes y to a negative. And the abbreviation, they use the letter M for reflections, and they just say 0x, and that just means in the x-axis. So copy that and come across. Okay, the next one we're going to do is in the y-axis. So this time it's coming across to a new point here. So it's going to be P dash, x dash, y dash. And looking at the symmetry, the x has changed to from the old x, but the y is still the y. So what I want you to do is think about what matrix that would do. Have a go. When you're ready, come back and I'll see how I've done it. Okay, so we've got minus 1, 0, 0, 1. So this minus 1 turns the x to a negative, and that y turns it into stays as a positive. And the abbreviation is M for reflection and 0y. Okay, next one. So now we've got a reflection in the line y equals x. So this time we're going up here, so the distances are the same. So P dash, x dash, y dash. And you can look at the symmetry, but basically the new x is the old y, and the new y is the old x. And to get that in a matrix, you just switch the numbers like that, and that'll get them to switch over. And the abbreviation for that is my equals x. Okay, next one, y equals minus x. So we're coming across to here somewhere. And again, with the symmetry of the line, x dash is the y with the change in sign. The new y is the old x with a change in sign. So the matrix would be 0, minus 1, minus 0, 0. So these numbers change the x's and y's over. And the abbreviation is y equals minus x. Okay, coming across when you're ready. Okay, so now we've got a reflection in the line. So basically, that distance is that distance. So that is a new point. So P dash, x dash, y dash. And basically, this distance here is the same as that distance there. So x minus a is the same as a minus x dash. So these distances, so the distance from x to the line is x minus a, and that's the same as the distance from a minus x. And then if you make x dash the subject, okay, so bring x dash to the front and take all the others the other way, you end up with 2a minus x. And so it's not a matrix this time, but the new x is 2a minus the old x, but the y doesn't change. And I haven't written down an abbreviation for that. So let's just say x equals a. But in my notes, I don't have an abbreviation. So maybe that's a bit dodgy. You'd be given that as a word in words. Okay, come across when you're ready. Okay, so this time we're reflecting in the line y equals a. So we're down here somewhere. So that distance is the same as that distance, P dash, x dash, y dash. And by the same idea, the x is the same, but the new y is 2a minus the old y. again, you'll be getting some examples on how to use all these formulas. Okay, so the next one we're going to do is in the line y equals x, and I'm just looking through my notes. Y equals mx, I beg your pardon. Now, I've just written down the answer. Look, so I'll just give you what it is. So a line y equals mx makes an angle theta with the x-axis, and the conversion will be this conversion. Okay, and one of the things you need to know, which we actually don't study until we do trigonometry, is there's formulas for cos 2 theta, and cos 2 theta equals 2 cos squared theta minus 1, and the formula for sine 2 theta equals 2 sine theta cos theta. So at the moment, just put those down, and when we do the trig unit, we'll actually be doing a lot more work on that. The abbreviation for that, I've got abbreviation my equals mx. Okay, rightio. So let's look at, I think I could close the bracket there. So let's look at some examples. Find the image with equation y equals x squared under y equals x. So first thing you do is you need to look at what that matrix is. So my equals x equals 0, 1, 1, 0. And so every point on that line will have a new point, which will be x dash y dash, which will be 0, 1, 1, 0 times the old points, x, y. And so ends up x dash equals y, y dash equals x. And so the original formula was y equals x squared, but now y becomes x dash, so x dash equals y dash squared. And then the final step is, once you've got that, you're nearly home, and you just the last step, you just take off the dashes. And so that's the final answer. So when that is reflected in that line, you end up with that. So basically, I'm hoping I can get this right. So the original one is y equals x squared, and when you reflect it through y equals x, my curve's a bit dodgy, you end up with x equals y squared. Okay, so the blue line is x equals y squared, and the red line was y equals x squared. So it's a bit, so that orange line should have gone through that point there. Okay, so let's look at the next example. Okay, so you need to find a matrix for reflection line y equals 2x. So this is y equals mx, a y equals mx equation. And under this transformation, find a new equation. So the first thing we do is we know that m equals 2, and the gradient is always tan theta. So we can draw a little right angle triangle and put theta, and tan is opposite over adjacent, and then using Pythagoras we get root 5. So now we can get an expression for sine theta and cos theta, because we need that because the matrix we need is cos 2 theta minus sine 2 theta, sine 2 theta, and oh, hang on, got that wrong. That's not a minus sign, that's just a normal. Okay, just make sure I got my, yep. That's a sine, and that's minus cos 2 theta. That's a minus sign. So when we look at this triangle down here, sine is 2 on root 5, and cos is 1 on root 5, just by using SOHCAHTOA. Okay, so now we've got sine 2 theta equals 2 times 2 on root 5 times 1 on root 5, which is 4/5, and cos of 2 theta equals, looking at my notes, 2 times 1 on root 5 squared minus 1, which is 2/5 minus 1, which is minus 3/5. Okay, so now Now we've got those answers. So we've got the new x and the new y equals this matrix. So we put minus 3/5, 4/5, 4/5, and 3/5 times the old x and y. So x dash equals, multiplying rows by columns, we end up with minus 3/5 x plus 4/5 y, and then multiply through by 5. So 5x dash equals minus 3x plus 4y. So that's one equation. And then the second equation, y dash equals 4/5 x plus 3/5 y. So 5y dash equals 4x plus 3y. So that's the second equation we need. Okay, so now what we do is we look at the original equation. Okay, so we look at this equation now. So we've got 5x dash equals minus 3x. Now we've got to get rid of the y by looking at the original equation, and the original equation was y equals x plus 2. Okay, so y equals x plus 2, so we get minus 3x plus 4x plus 8, so we end up with minus x plus 8, and so x equals, so move that across and move the 5x back, so end up with so it's a plus x, so don't move that at all. So minus 3 plus 4 is plus 1, so just move the 8 across. So we get 5x dash minus 8. And so that's what we'll use for the substitution. Similarly up here, we've got 5y dash. Now, y equals x plus 2, so x equals y minus 2. So we've got y minus 2 plus 3y. We're trying to get rid of the x, so we've got 4y minus 8 plus 3y equals 7y minus 8. And so 7y equals 5y dash plus 8. So y equals 5y dash plus 8 over 7. Okay, so now we've got an expression that we can now go to back to the original equation. So the original equation was y equals x plus 2. And so we can put 5y dash plus 8 over 7 equals 5x dash minus 8 plus 2. So there's your x. Okay, nearly there. Oh, jumped up. So we got 5x dash minus 8 plus 2. Hang on a sec. Yeah, I was just looking at my notes. I made a mistake in my notes. So minus 8 plus 2 equals minus 6. Then multiply through by 7 to get rid of the denominator. So we get 35x dash, and 7 6s are 42. And then 5y dash equals 35x dash minus 50. And then just divide through by 5. So y dash equals 7x dash minus 10. And so the last step is just take away the dashes. So the line y equals x plus 2 reflected in y equals 2x becomes y equals 7x minus 10, which is quite neat at the end. And that's the end of our slide. So that was a big one, but hopefully you'll get enough practice to understand what you need to do.